March 3rd, the moon turns blood red directly over Hawaii. And at that exact moment, a volcano that's blown 42 times in 70 days is on track to erupt again. Lava fountains taller than the Empire State Building, shooting into darkness under a blood-red moon. But that's just what your eyes can see that same night. A brand new telescope that went live 6 days ago will be scanning the sky above. And it's already caught something that honestly shook me. A star that didn't explode, didn't go supernova, it just vanished straight into a black hole. No bang, no light, just gone. Stick with me. By minute 6, I'll show you why NASA just gutted its moon landing plan. The same week, we're watching the moon turn red. And at 2:30, there's a number about Kilauea that'll genuinely mess with your head. Don't skip ahead. It all connects in a way you won't expect. Let's go. March 3rd, total lunar eclipse, blood moon. Here's what happens. The moon slides fully into Earth's shadow and goes this deep, eerie. Red. Not orange, not brownish, red. And the reason it goes red instead of just disappearing is actually beautiful. Earth's atmosphere bends. Sunlight around the planet like a lens, but only the red wavelengths make it through. Same reason sunsets are red. So what you're looking at is every single sunrise and sunset on Earth all at once bouncing off the moon and hitting your eyes. That's low-key one of the most poetic things in all of astronomy. Now, who gets to see it? If you're on the West Coast, Cali, Oregon, Washington, you get the full show, start to finish. Peak totality hits 1:34 a.m. Hawaii time, most of north. America sees at least the total phase. East Asia, Australia, New Zealand, you're good. Europe and Africa, nah, you're on the wrong side of the planet, won't see a thing. But here's where this story goes from cool to absolutely nuts. Hawaii, dead center of the eclipse. And right there on the Big Island sits Kilauea, one of the most active volcanoes on Earth since December 23rd. This thing has had 42 episodic eruptions, 42 in about 10 weeks, and they're not leveling off, they're escalating. The lava fountain started around 1,000 feet, then 1,000, then 1,200. The most recent ones topped 1,500 feet taller than the Empire State Building. Every eruption bigger than the last. And here's the number I promised you. Here's the math that stopped me cold. The average gap between the last 9. Eruptions 13 days. The last one ended February 16th. Do the math. February 16th plus 13, you land on March 3rd, the exact date of the blood moon. Now I'm going to be real with you. That's the average. Actual. Gaps range from 10 days to 22. Could happen March 1st, could be the 7th. But the single most likely date, March 3rd, right under the blood moon. Picture this. You're a photographer on the Big Island. It's 1 a.m. Tripod's out. The moon overhead is turning this deep blood red. And behind you, Kilauea blows. A pillar of glowing lava. Maybe 1,500, maybe 2,000 feet tall. Lighting up the night under a red moon. That's not sci-fi. Based on the data, that is literally the most probable outcome for that night. And it's not just Kilauea going off. The whole ring of fire has been acting up this past month. Magnitude 7.1 deep. Earthquake in Malaysia, 6.4 in Vanuatu, followed by eruptions. Deep. Quakes near Fiji. The entire Pacific is rumbling, and right in the center of all that chaos, the moon's about to go dark. Now, this specific alignment runs on an 18.6-year cycle. A blood moon centered over Hawaii, right over a volcano that's erupting on a 13-day clock. That combo is not repeating anytime soon. This is a one-shot deal. And here's the kicker. That full moon gravity isn't just moving the ocean. The same tidal pull that creates big waves, it tugs on rock, on magma. On the molten guts of the planet, it's a small effect, not gonna lie. But when you've got a volcano on a hair trigger, already popping off, every couple weeks with increasing force, it's like a glass wobbling on the edge of a table and someone bumps it. Most of the time, nothing. But that glass was already wobbling. Oh, and real quick eclipses. Specifically, don't make quakes worse than a regular full moon. That's been studied. No extra effect from the eclipse itself. But the full moon tidal stress is real. And it's landing on the same night as all of this other stuff. That's a whole lot of coincidences stacking up. Okay, so while you're out there looking up at the blood moon on March 3rd, something else will be watching the sky that night too. Something way more powerful than your eyes and what it's already found, honestly. It's scarier than the volcano. Let me tell you about the telescope that just woke up. February 24th, less than a week ago. A new observatory called Vera Rubin went fully live, and this thing is absolutely bonkers. Every 40 seconds it snaps a photo of a chunk of sky. Moves to the next, then the next, non-stop, all night, every night, for the next 10 years. And every time it circles back to a spot it already shot. Its computers compare old versus new. Anything different. New dot. Missing dot. Something moved. Bam! Alert goes out within 2 minutes to astronomers worldwide. Hey, this spot just changed. Go look! And on. Its very first night, day 1. Not even warmed up yet, Vera Rubin. Issued 800,000 alerts. 800,000 things that changed in the sky in a single night. Supernovae, active galactic nuclei, asteroids. Stuff we don't even have names for yet. And that was just night 1. Running on limited software. When fully cranked up, they're projecting 7 million alerts every single night. And here's the wild part, this data is public. Open to everyone. You, me, some kid in Iowa with a laptop. Regular people are going to be finding supernovae before professional. Astronomers even wake up. Think about that. The biggest discovery of the next decade might not come from a PhD. Might come from somebody on their couch at 2 a.m. scrolling a data feed. That's the world we just entered. Welcome to it, but Vera, Rubin isn't just spotting new stuff. It's catching things that vanish. And this is where the story takes a dark turn. Literally dark. There's a theory that certain massive stars, when they die, skip the fireworks. Entirely. No supernova. No explosion. They just quietly collapse into a black hole. 1 second there's a star, next second nothing. Gone. Astronomers are calling it an unnova, the opposite of a supernova, and they think they just caught one red-handed using data. From NASA's Neowise spacecraft, they tracked a star in a distant galaxy. From 2009 to 2022. In 2014, it got brighter, and then by 2022, poof, gone. Hubble confirmed missing invisible light, just a faint whisper, in infrared, like a ghost. Now think about how nuts that observation is. A galaxy can have 100 billion stars. You gotta notice that one of them went missing. That's like noticing a specific grain of sand disappeared from a beach. Now picture Vera Rubin doing that check every 40 seconds, across the whole sky, for a decade. How many more unnovas are out there? How many stars are quietly dying right now, folding into nothing, while nobody's watching? Well, now somebody's watching. And it doesn't stop there, because it's not just stars vanishing. Astronomers found what should be an entire galaxy, except it's nearly invisible. They spotted clusters of ancient stars orbiting around nothing, just apparently empty space. But when they turned big telescopes on the area faintest possible glow, tiny red dwarf stars, a galaxy made almost entirely of dark matter. 16% of its total light was coming from those star clusters alone. That's insane for a galaxy. In the Milky Way, that'd be like nothing. So check the pattern. The moon vanishes into shadow on March 3rd. A star vanishes into a black hole. A whole galaxy exists almost invisibly. Everything's disappearing. And we're finally building the tools to catch it, which is perfect timing. Because the biggest disappearing act this week wasn't in space. It was in a press conference on a Friday morning. And it changes everything about when humans get back to the moon. Don't skip this. Here's your Minute 6 payoff. You remember the Artemis program, right? NASA's big plan to put boots back on the moon. Artemis 1 uncrewed test. Loop around the moon done. Check. Artemis 2 crew of astronauts fly around the moon without landing, supposed to launch this spring. Artemis 3, the big kahuna. Humans on the lunar surface, first time since 1972. Well, Jared Isaacman, the billionaire who personally flew a SpaceX mission to orbit, did a spacewalk, and now runs all of NASA. This dude stood at a podium on Friday morning and dropped a bomb. Artemis 3 will no longer land on the moon. Let me say that one more time, because I need you to feel the weight of it. The mission that was supposed to put Americans back on the lunar surface, the whole reason Artemis exists, got downgraded to a docking test in Earth orbit. That's it. No moon, no landing, just a rendezvous with whatever lander happens to be ready, SpaceX. Starship, or Blue Origin, the actual landing pushed to Artemis 4. Targeted for 2028, if that holds, and here's why this is happening. Right now, Artemis 2 just hit a wall during the wet dress rehearsal. On February 19th, where they load the rocket with fuel and simulate launch the liquid helium system, crapped out. Helium pressurizes the hydrogen and oxygen tanks and keeps the engines at the right temperature. Without it, you don't have a rocket. Problem's bad enough that NASA's rolling the entire space launch system back to the assembly building. For repairs, March launch dead, April's the new maybe, so here's the irony I can't get out of my head. This week, we will look up and watch the moon turn blood red, the same moon we keep promising to go back to. And the same week, that promise got yanked. Again, we can photograph auroras on a planet 1.8 billion miles away. I'll get to that in a sec, but we can't get 4 astronauts to a rock 240,000 miles from here. Drop a comment. Do you think 2028 is realistic for a moon landing? Or are we just kidding ourselves at this point? I want to hear it. Seriously, 2028 real or nah? And while we're at it, if you're somewhere you can see the eclipse, drop your city too. I want to know where y'all are watching from. Okay, speaking of seeing things far away, while we're fumbling with the moon, James Webb just did something wild with Uranus. Yeah, get it out of your system. You done cool, because this is legit incredible. Webb captured one full rotation of Uranus and mapped its atmosphere in 3D, tracked high-altitude clouds separately from low ones, and caught auroras, glowing lights on a planet nearly 2 billion miles from here. Uranus is tilted 98 degrees. It basically rolls around the solar system on its side like a bowling ball. Something massive whacked it billions of years ago and just tipped it over. And yet magnetic field's still going, aurora's still firing, weather's still spinning. And here's the thread that ties it all back. Those auroras on Uranus, same cause as the northern lights on Earth. Solar wind. The sun blasts charged particles in every direction. Hits Uranus, hits Earth, hits the moon, pushes on our magnetic field, tugs on our interior. The same sun that's lighting Uranus on fire too, billion miles out, is also giving Kilauea that extra little nudge. Right now, it's all one system, one star driving everything, from the aurora on a sideways planet to the lava under a blood-red moon. And real quick, that same solar wind, it creates a massive bubble around our whole solar system called the heliosphere. And Voyager 1 and 2 already punched through it. They're drifting in interstellar space right now, outside the sun's protection, and those golden records they carry. Sounds of Earth, a baby crying. Greetings in 55 languages will still be readable a billion years from now. Long after everything we've ever built is dust, the sun's wind lights up Uranus, shakes Kilauea, and built the very bubble Voyager had to escape to carry our message. Into the void. One star. Everything connected. All right, let me land this plane, because here's the thing nobody's saying out loud, and I think it's the most important takeaway from all of this. 100 years ago, we didn't even know other galaxies existed. We thought the Milky Way was literally everything. Now, in 1 week, we turned on a telescope that spots invisible galaxies made of dark matter. We caught a star quietly collapsing into nothing in a galaxy, billions of light years away. We photographed auroras on a planet knocked sideways 2 billion miles from here. We are seeing things. That would have been literal magic 50 years ago. The question is no longer, what can we see? The question is, what's disappearing? Right now that we haven't caught yet, how many stars are folding into darkness tonight? How many galaxies are drifting through the void made entirely of stuff we can't see? And what does it say about us that we can detect all of that, but we still can't get back to a rock 240,000 miles away? On one night, March 3rd, your eyes stars vanishing into black holes, and the plan to land on that moon. It vanished too. Same night, same sky, same moon. That's either the most awe-inspiring week in space or the most frustrating one. Probably both. If you're anywhere the eclipse is visible, go outside, look up. You don't need a telescope, don't need special glasses, just your eyes. And the moon. Binoculars help. Clear sky helps more, but you'll remember seeing this. And if Kilauea cooperates, you'll be watching one of the rarest collisions of celestial and geological events in living memory. Drop your city in the comments. Let me know if you can see it from where you are. If you're on the big island, dude, get your camera ready. That shot might be once in a lifetime lava. Fountains under a blood moon if that actually happens. Those images are going to be everywhere. You'll want to say you saw it live now. Next video, you know the exoplanet K2-18b, the one some scientists think has a global ocean under a hydrogen atmosphere. This week, 2 of the most powerful radio telescopes on Earth pointed straight at it and scanned for signals from intelligent life. Did they find anything? That's next. And trust me, the answer's more complicated than you think. Hit subscribe so you don't miss it.